right? Also, again, this link in the chat, remember, it's also on Blackboard, okay? You know, if you can't find it, let me know. Okay. All right, let me get the notes going. All right. So again, here, right, we have this example to do, right? We want to have $800,000 in our retirement account in 30 years, okay? So here, remember, and also here, the account is earning 6% interest, okay? The account is earning 6% interest, okay? Now, we want to know how much we need to deposit into the account each month. So it's really just like the previous question. In that, we want to know what our monthly deposit needs to be, okay? We also want to know how much total money we'll put into the account and how much total interest we'll earn. I mean, if you didn't finish this in 3 minutes, that's fine. I mean, maybe if you used the Tbm Solver, you probably could have, but that's okay. All right, anyway. And also notice that we're making many deposits, not just one. So we actually do have what's called an annuity. All right. So using our formula, this is our formula here. What we would have, you know, the balance were after T years is $800,000. That's what A represents. You know, we know that, right? We know that. Okay. The PMT, right? That's our regular deposit here. Okay, you know how much we're depositing into the account each month? And that's what we want to know. We're looking for that. R is our annual interest rate as a decimal, the APR in other words. So that here is 0.06. N is how many compounding periods there are in a year. Now, since we're making monthly deposits, right, that tells us it's being compounded monthly, so N would be 1. Okay, so N is 1. Now, T is how many years we plan to make deposits, monthly deposits. In other words, T is time for us. And in the problem, it said 30 years. Okay, cool. So let's do this. This is our formula. We plug it in. PMTs are unknown. And it's really just like what we did before, as you can see. You want to work with the innermost parentheses first, which is the 1 plus 0.06 over 12. So, you know, you do the quotient, right, which is 0.005. Then you add that to 1. Okay? And then what do? Well, then you have 1.005. You know, you get the exponent, which is 360, 12 times 30. And again, we're using PEMDAS here, right? We're working in the parentheses. So we raise it to that exponent. We get this. Then subtract 1. Okay? And that's going to give us this. So this whole thing is equal to $800,000. You know, we have these equal signs, right? So, right, so what we did remember was we did this quotient. That's how we got this wonderful line here. And then we just divide. And we get about this amount. You know, I mean, I didn't round it to 2 decimal places, but you could see it would be $796.40. So that's how much we would have to put in each month. Oh, what time? I want to give people a chance to see this. Okay. Are there any questions about the formula use? All right. Now, let's use the Tbm solver. Okay, so just like before, FV, what does that stand for? Future value, right? That's how much will be in the account in the future. So in this case, FV is $800,000. Okay. We want to know our monthly deposit, right? So PMT is what we're looking for. I is the interest, but you leave it as a percent, 6% in this case. Capital N, right? That's how often the account is compounded, which in this case is 12 times 30. I mean, it's always little n times t. So in this case, it's 12 times 30, which is 360. PV is 0, right? There's nothing in the account to begin with. Now, then P/Y, C/Y. Again, this is how often we're making payments. Deposits, I mean. I know it says monthly payments, but really it should be deposits. But hopefully everyone understands. It's also equal to, and they're both equal to 12. It's also how often the account is compounded in a year, which is 12. And they're always equal to each other. And just to illustrate how the Tbm solver, let's actually go to that. So I have to stop sharing this. Let's go to that Tbm solver. There we go. Here it comes. Okay, good. All right, so let's put the data in. We have capital N, right? That's 12 times 30. I mean, you could type 12 times 30, but let's just could type that. I is 6. I think that's what we said. Yeah. PV is 0. That's how much is in the account initially. PMT is what we're looking for. So PV is 0. That's how much is in the account. PMT is what we're looking for. FV is 800,000. We said P/Y is 12. Both of these are. Okay. You know, again, it's how often we're making deposits or how often compounding is done in a year. How often we're making deposits in a year. How often the account is compounded in a year. And they're both always equal to each other in this class. Theoretically, they don't have to be, but in this class they are. So let's solve for PMT. We get this, which was the same thing as before. Again, it's negative. Is that bad? No, because remember, negative means a cash outflow. Money's going away from you. Even though it's going into an account, it's still considered a cash outflow. All right, good. Any questions on this? Okay, let me stop this then. Go back to the notes. Okay. So now we have our monthly deposit. Okay. So again, part B was how much money in total do we put into the account? Well, again, if that's our monthly deposit, right, the $796.40, right? And so this is going on for 30 years, right? Well, then how much are we going to put into the account in total? Well, we have $796 per month, 12 months per year, right? These units cancel. So, and then 30 years, right? So the units here cancel. So we have $796.40 times 12 times 30, which equals $286,704. And again, whatever is left over came from interest. So we subtract $800,000 minus how much in total we put in. Well, the rest came from interest, and that's what this amount is. Okay, any questions on that? All right, I mean, we have seen this kind of problem before as well. Basically here, we have that retirement account, right? And we want to be able to take out money once we retire. So here, we want to withdraw $1,500 each month for 25 years. That's how much we want to be able to withdraw. The account earns 6% interest. But here the question is, how much do you need in your account when you retire? So this kind of account is what we call a payout annuity.